So do you remember radians from Algebra 2? Okay, what do you remember about them? Okay? It is dealing with a measurement. What do we measure with radians? Well, what do we measure? Angles. Okay? We measure angles with radians or with degrees. Okay? I'll say that oftentimes degrees is more helpful for when you're doing applied type problems. However, in the theoretical, radians is far superior. Mainly because it makes computation so much easier in a lot of cases. I'm going to show you a couple of the cases today where the radians are superior to degrees. Now, first thing before we talk about radians, a type of conversion you need to be able to do. You know what DMS stands for? Any guess? Yes, degrees, minutes, seconds. So no, we can measure an angle in seconds. Or we can measure it in minutes or in degrees. And that's all basically the same unit. How many seconds in a minute? 60. How many minutes in a degree? 60. Okay? 1 degree equals 60 minutes. We're using it to measure different things. But yes, 1 degree is equivalent to 1 hour. It's the way it was chosen. Why were minutes and seconds used? I believe originally it was designed for how fast you could travel around the globe. And how many minutes you cover, like a latitude or longitude. I believe that's what originally dealt with, but I don't know. This might have even been before degrees, minutes, or degrees, hours, minutes, seconds. It might have, I don't know. So 1 minute is 60 seconds. So everybody follow that? Does that make sense, right? Okay, so if I had 35 degrees, 21 minutes, 15 seconds. This is the notation you use. 35 degrees, 21 minutes, 15 seconds. That question you need to give, how do I change it from degrees, minutes, seconds into just degrees without a decimal? So first, how many whole degrees are there going to be? 35, good. What fraction of a degree is the minute? Well, each of them is 1/60th of a degree. If there's 60 minutes in a degree, so you can write this 35 plus 21 over 60. Does that make sense? Where 21 came from and where 60 came from. Now, how many seconds in a degree? Yeah, 15 over 3,600. 3,600 came from 60 times 60. So there are 60 changes this to minutes, and 60 more changes it to hours, or degrees. Well, just because we're looking for a decimal answer, it's one just calculator as it is. Remember, we are looking for a decimal fraction, a decimal thing, not the fractional part of it. So what do you get when you plug this into your calculator? So 35.3541 6, 7. Well, you want to at bare minimum 4 decimal places. Oftentimes they'll say random 4, so I put 6 up there. Does that make sense how we did it? So that one's fairly simple. And okay, how about going backwards, the other direction? So if I had, say, 22.1763 degrees, and I want to change it to degrees, minutes, seconds, so I should put a degree there. First, how many degrees is that going to be? 22, okay, that's the easy part. So now we can get how many minutes and how many seconds. Okay, the easy way is we're going to take, so put this into your calculator, and then push enter. Yeah, push enter. Then put minus 22, and then enter. Not negative 22, minus 22. So we should get just this 0.1763. Now how many minutes in a degree? So multiply your answer times 60. Because we have this decimal of a degree, and we want that decimal out of 60, right? So what do we get when we multiply this 0.1763 degrees times 60? 10.578. Is that it? So this is now minutes. By multiplying by 60, we change from degrees to minutes. Oh, remember, each degree has 60 minutes, right? So if I had 2 degrees, how many minutes? 60 times 2. If I had 5 degrees, 60 times 5. So if I have 0.1763 degrees, multiplied by 60, I get the number of minutes. So I get 10.578. So how many minutes do I have? 10. That's going to go here. Then what? Well, we're not finished yet. Because remember, the rest of this, we want to change the rest of this into seconds. Well, how many? This is minutes now. So how do I change minutes into seconds? Yeah, times 60. And what do I get? .68 seconds. So 22.1763 degrees is 22 degrees, 10 minutes, 34.68 seconds. Yeah. Okay. So I subtracted 10 because I took that 10 out and put it right here. The same way we took this 22 and put the 22 there and just middle of that. Okay, so fairly easy if you just think about how we would change this back and forth between these units, right? Now we can get into degrees and radians. The reason some of the problems they'll give you in this form, and that form is not useful if you're actually doing trigonometry. Because we need to change it to the decimal answer. Now, if I know how to do, there's actually, you can have your calculator do this for you too. Let me see. I don't remember how. I'd have to play around a little bit, but I believe, yeah, there is a degree button, an angle, and a degree button, and there's a DMS button that changes degrees, minutes, seconds. So, when we measure, or when we have a graph, where is the first quadrant? There? Yeah, so this is quadrant 1. This would be, this is, and this is. Yeah. Why do we number them in that order? And wouldn't it make more sense to do 1, 2, 3, 4 with our standard mind? Okay. So what we're dealing with angles. And starting off, we want angles in standard position. So standard position always starts on the positive x-axis. And then we have our other angle, or angle from that. There. So we get this angle right here. And think about what the path the second edge would go if you're going to get to this point. We would start over here and then measure it upward around. So we go 1, 2, 3, 4. Now what happens if we went the other direction? What would happen to the angle, we think? Now we get negative angles if we go the wrong direction. So positive angles this way, negative angles that way. So about how big is theta here? Yeah, 135, a bit less than that. 135 would be the middle. So let's just say it's about 120 degrees, or 120, 125, somewhere in that neighborhood. How big would it be if I was doing this angle right here? We call that one theta. How big is that angle? Negative 240. Because it's going downward and around. We're going downward, it's going to be a negative. And how about I throw one more angle up here before we get to, let's see, this angle here, and how big is that angle? It's going to be positive or negative first. Okay? That means it's going to be a negative angle. How much is it all the way around? 360. And then this would be how much more? Another 90. So 450. So it starts here. Okay. Which is just supposed to start there. I'm sorry. I drew it wrong. So starting here, you got 360, 450, 540. What? 540. Like 540. Yes, 540 is here. 90 degrees more. 630, and then a little bit more. How much more does that look like? Maybe 20 more, 15 more. So C would be, or the pink angle would be approximately how many angles? Negative 6, 45 degrees maybe. How big of angles could we draw on this? Could you draw a 1,000,000-degree angle? Anyone want to do it for me? Okay. Where would a 1,000,000-degree angle end? How can you tell where it's going to end? Hey, how do you get that? Okay, so that's 2777. So what? 2777 times 360. Let's just do 2777 times 360. That's what that means. Okay. It's 2777. Okay, and just take 1,000,000 minus that number. Okay, so 280. So it's the same as the 280, it's the same position as 280 degree, which is, as you were saying, fourth quadrant. So we could say an angle right here, 280, this is a 1,000,000 degree angle. Well, 2,000 sometimes. 2,777 times.
Right.
But it would end about there, and that's a 1,000,000 degree angle. Now we also need to start talking about radians. Nope. It's too late. And some memorization you're going to need to do. They may have already done. Yes. Yes. Yes, algebra 2. So, if we have the angle that goes here and then back, how big is the angle in degrees? So, 0 degrees, how many radians? 0. So, it's something to note. If I see this answer without a degree symbol, it says radian. So even if you wrote 23, that's radian answer. Unless you put 23 degrees. So this is radian, this would be degrees. So no degree symbol implies radian answer. So everybody with me on that. If you do not write your degree symbol, I'm going to assume you're using radian. So, how about straight out? How many degrees? 90 degrees. How many radians? Okay, half a radian. What do you mean half a radian? Pi halves radian. No. How many radians are in a circle? All the way around. 2 pi radians. Does that sound familiar?
Oh, yeah.
So all the way around is 2 pi. What is 2 pi as a number? What is approximately? About 6.28. So there's about 6.28 radian in a circle. So half a radian would be how much of a circle? About a 12th of a circle. Yeah, remember that we said there's about 6.28 radians around the circle. Right? So straight across here would be about 3.1 radian, 3.14. So this would be half of that, so about 1.56, something like that, radian. Take a third of that, and it would be about half a radian. Do you follow that? Remember, pi's are not radians. It's convenient to measure radians in pi. Oftentimes we use a fraction of pi. However, just because we say is pi halves, so I could say it's something that's pi halves degrees, right? What would pi halves degrees? What would it be as a decimal? So it's pi divided by 2. Okay, 1.57. So if I said this is pi halves degrees, this is about 1.57 degrees. And that would be a completely legitimate thing I could do. You have to watch, is it degree or radian? So very likely I have quiz, I'm going to try something like that. Okay, so if right in the middle, how many degrees is it in the middle here? 45 degrees. How many radians? Pi 4. So you got 0, 45, 90. This one? So it's 3 pi 4. Or how many degrees? Okay, over here. Okay, pi and how many degrees? Down here. 270 degrees, 270 degrees. And how many radians? 3 pi over 2 here is 5 pi over 4. How many degrees? Okay, here. 3 pi over 2 is true again. Okay, 7 pi over 4 and degrees. 325. 15. Okay, and all the way around, how many degrees? How many pi? So, first test, all that memorized. Yes. Just getting your degrees rating for those 8. Right. Some of you sound like you already have it. Should be able to do it fairly quickly. So maybe I'll say, if you have a 30 or 45 degree angle, how many radians do you have? So it should be fast enough that when maybe I might have, what if I get negative 90 degrees? And 5 or 2. So each one of these you should be able to answer in less than 10 seconds. So what I'm going to do for a quiz is not write any on the board, but do it entirely orally. And just this, change it from degrees to radians or radians to degrees. And say, okay, for example, 90 degrees. 270 degrees. And then just keep going about that speed. So about 10 seconds. Yeah, you would write down the answer. And just changing the back and forth between radians and degrees for these. There's only 8 values there. Eventually we're going to get about twice as many. And then, yes, and then add in more stuff too. So you remember the unit circle from last year? Memorize. So you should be able to answer any question about it in 10 seconds or less. No. This by tomorrow. I know, 10 seconds is a fair amount of time. And most of you are answering in 5 seconds. Which gives you 5 seconds to write it down. And, like, for example, 315 degrees. Okay, so not always a bit slow. But that's the general idea. That was 10 seconds about when you answer. No. What it is. Can't stand from 10 twice. Or from 5 twice. It actually ends up a little bit more than 10 seconds, but it was in that neighborhood. Now for the numbers that are not so nice. So what if I said convert 23 degrees to radians? There's a nice formula for you to memorize. What? A nice formula to memorize. What is equivalent to 180 in radians? So this formula will change it back and forth between degrees and radians. Have you seen it before? Oftentimes I don't think I've seen a book that actually puts this in there in this form. They just say to change from radians, they say pi times degree over 180. But I'd rather have just a single formula that's both ways. So if you have 10 degrees, how many radians is it going to be? So you do 10 over 180 degrees equals radians over pi. Okay? Your degrees are going to cancel. 10 over 180 simplifies to what? So 1 over 18 equals radians over pi. Multiply over pi. So we get pi over 18. So 10 degrees is pi over 18, or 1/18 of pi. What? No, what's the answer? What do you mean? I don't want a decimal answer. No, decimals are bad unless it actually splits two fractions. Don't use decimals unless it says specifically use decimals. In most cases, you want a fraction of pi as your answer. Yeah, 23 over 180. Yeah. Or 23 degrees. Yeah, you can't simplify that further. Yeah, 23 pi over 180 degrees.
What did you say? 1 radian?
What is what?
1 radian.
1 radian is about a 12th of a circle. A little less than a 12th.
So, degrees.
And degrees?
No. 1 radian is what degrees?
Okay, let's do that. 1 radian, pi, equals a degree over 180. How do we solve that? So we get degree equals 180 over pi. Now this one, how is this different? We have an irrational number in the denominator, which means that we would want to use a decimal answer for it. So what is 180 divided by pi? A 5.32 degrees. That's my God, that's awfully big. 57.32 degrees. There you go. Jimmy, 1 radian about 57.32 degrees.
I don't understand 57.39.
Did you divide by 3.14 or divide by the pi button? Do you, what do you? Yeah, that's, okay. So what is it? 57 point how many?
296.
Okay, so 30.
It's not 12.
Yeah, it's not. Oh, so that is 6 of the circle. That is 6 of the circle. Sorry. 12 is wrong. Because I think it's 1 pi in the circle, but it's actually 2 pi. Okay, so you do pi divided, or 180 divided by pi. Now, some of the uses of radians. First, we have arc length. You get a nice formula. S equals R theta. What is an arc? So the arc is, you have this as an arc. And if you're using this formula, theta is in radians. What is R in this formula? Radius. So if you know the radius and the angle, we know the arc length. How would you have to do this if you were doing it with degrees? Like I told you, this was, say, 20 degrees and radius equals 5. Okay, you could convert to radians. However, if you're not doing that, you'd have to say C equals 2 pi r. So circumference of the circle is equal to 10 pi. We want to do 20 out of 360 of it. So 20 over 360 times 10 pi. However, in this process, we actually are converting to radians. S equals R theta is the one you want to use.
So it's never going to ask us for the answer in degrees?
Well, this is asking for arc length, so if it gives you degrees, the first thing you want to do is change it to radians.
Arc length has 3 radians.
Well, arc length is in meters, or feet, or some distance. how far did it travel? So how far is it if you walked along this line? And if you tells you this is in degrees, if this is 35 degrees, first thing you want to do is change it to radians, because it makes it much easier. Because then all you have to do is plug that in here, multiply the radius, and you get your answer. Versus if you didn't, you'd have to do the whole process where you do 35 over 360 times 2 pi r. That's probably the method you use in geometry to do this. It's easier just to multiply or change it to radians, which is the same thing you would be doing. Second one, area of a sector. You know what a sector is?
This is the last one.
Last formula, yes.
The maximum.
I'm going to show a couple of types of problems you want to do.
That's right.
So this is like a pizza slice. So A equals 1/2 r squared theta. Theta in radians. For these ones, yeah. Yeah, those are last big type problem or equation. So if you weren't using radians, if you were in degrees, you would have to say like 35 degrees over 360 degrees times pi r squared. You see connection between these. And it is the same thing. You are, when you're actually doing this using degrees, you're actually changing it to radians and then doing it. You are using this formula, you just don't realize you're using it. Now, one type of question it's going to ask you on this homework that we haven't talked about. These are the relatively easy ones. Give all angles coterminal with, let's say, 25 degrees. And I'm also going to do one, say, 7 pi fifths. So two different problems. One that's 25 degrees and one 7 pi fifths. All angles that are coterminal with it. How many angles are coterminal? How many times can you go around the circle? Infinite. So we want to list every number, every angle. So how long is it going to take you to do that if you just tried writing them all out? For eternity and then some. So we'd rather not have to be writing for eternity, right? Where is 25 degrees on the circle? 25 degrees somewhere around here. How could I get to another angle that was coterminal with it, or into the same spot? And I could go here and add 360, right? And how could I get to the next one? Add 360. Or I could subtract 360. So we've got a nice form. 25 degrees plus 360 degrees n, where n is an integer. So if I put in 1, 360 times 1, I'd have 25 plus 360. That would give you 1. If you plug in 15, 15 times 360 plus 25 gives you another 1. And this would give you basically an infinite number, because whatever number you plug in for n, as long as it was an integer, would give you a coterminal angle. How would you do it for 7 pi fifths? Okay, so what is the equivalent of 360 degrees? 2 pi. So you can do 2 pi n, where n is an integer. So this is a equation that gives us all angles that are coterminal with that first one. And that's how we get there. Why would we do 360? Because all the way around the circle will take you back to the same spot. Same reason why we choose 2 pi. And we're not plugging any number in. We're just saying that in whatever n we plug in would give us a coterminal angle.
Oh, the answer.
remember the question is all angles. And this would, if we, any number we plug in, coterminal means ending at the same spot or terminating on the same one.